Okay, I think I've got all the good stuff up and running. Maybe folks can let me know if things look okay, if you can see me okay. Hopefully you're doing well. Welcome to another day looking at Iceland. Folks can let me know if I'm 5 by 5, if you can see and hear me okay, that would be great. And we'll chat for a bit here and we'll get started in about 8 minutes. Hope you're doing well. Great. Manda Joe says it sounds good. Lisa, thank you for being on there as a moderator. Appreciate you. And happy St. Patrick's Day to anyone who's joining us today. Awesome. Yeah, I got some sleep. I hope you did as well, depending on where you are and where you're living. And we've got some fun information to share today with the eruption that began yesterday in Iceland on Saturday, March 16th. But we'll go ahead and give folks a few shout outs while we're just kind of getting warmed up here. Looks like we have lots of folks here. Sandrine from France, how are you? Thorsten says aloha. Chris from Netherlands. Way to show up this morning, team. Appreciate you. Thanks. Yeah, Deanna, I was watching Isaac's stream earlier, so I do know kind of where that flow's at, but thanks for providing that information. Always appreciated. Glenn from Winnipeg. Barbara from Sandpoint, Idaho. Phil from Fort Worth, Texas. I used to live in Fort Worth for a couple of years of high school. Who else is here? Crab Whisperer from Maryland. Robin from England. Glenn from Winnipeg, Canada. Casty says good morning. Lots of folks wishing a happy St. Patrick's Day, which is great. Dim from Luxembourg. Edith says hello. Backyard Farm Vet from New Brunswick. Richard from Port Orchard, Washington. Great, we've got folks coming in. Kira from Germany. Mitch from Saskatchewan. Susan from Canada. Greg from East Carolina. Scroll, the chat moves quicker than I can follow it sometimes. Pinball 1970 from Manchester, UK. Kate Batt from Cambridgeshire, UK. Larry from cloudy central New York. Sue from South Africa, welcome. Jan from the southwest corner of Canada. Would that be British Columbia? Just guessing. Zulia from Norway, hello. Norway's a beautiful country as well. We have, my wife has relatives there we visited once. Sabine from Cologne, Germany. I see your little hand waving. Hello. Excuse me. Sonora B from Houston. Rayola from McGuffey, Ohio. Al from Dorset, UK. Nieder Mama from Michigan. TL Klein from Pittsburgh. Joanne says good morning from South Africa via Australia. Look at you. Good job. Estelle from Perth, Western Australia. Yvonne from Twickenham, England. Awesome. Benjamin from Boston. Barbara from Weiser, Idaho. Jonathan's in Kent, Connecticut. Linda is currently in Paris, but usually when she's not in Paris, from New Hampshire. Poppy Agnew from Cincinnati, Ohio, USA. Freya from Scotland. Jan in southern Alberta. Hey, someone from Fruit Heights, Utah. I went to Layton High once upon a time. AP from Council, Idaho. Pam from Yorkshire, UK. Dixon from Roseville. Yeah, we got lots of folks here. Brian says hi from Ireland. It is St. Patrick's Day. That's pretty awesome. Harley's Corner from Estonia. D. Dorothy from Orangeville, Ontario. I'm missing several of you, and I apologize. I cannot read all of these that quickly. It's just too many, but I'm just kind of running through the list as quick as I can and grabbing a few here. So Susan's here as well. So make sure you guys are very kind and generous with our moderators, Amanda Jo, Lisa, and Susan. Let's see, who else? Lori from Dana Point, Margarita from Germany. Michael says, hi from my mom's basement. I've been there. That's okay. Nothing wrong with that. Benjamin from Iowa. Maria, Denmark. Julie, Haley, Idaho, just up the road. April from Central New York. Kim from Kalamazoo, Michigan. I always thought that was such a fun name for a town. Robin, Nebraska. Rod's out camping somewhere. Wendy is sleeping in California, but she's watching. Mumnemus from South Australia. Alan from Maine. Pipson from Denmark. Infinite from Visalia. Jean from Fairbanks. Greetings. Mary from Dublin. Happy St. Patrick's Day to you. Harley's Corner from Estonia. Maybe I read that one. Caroli the Retro Gamer from Thunder Bay. Claire from Norfolk. Geo Girl from Wiltshire, UK. John Allen, Indiana. Yeah, a couple more minutes of shout outs and then we'll get started here. Sue from London. Robert from wet northern England. John from Florida. Tom from the UK. Kevin from Santa Fe. Joe Jackson from a sunny Spokane, Washington. Nyaka 519 from the Netherlands. Vampy Twine from south of Sweden. William Baker from Pleasant Valley, New York. FSM is the dog from Cymru, Wales. I've been to Wales. Brian Griffin from Ireland. Happy St. Patrick's Day. Sophie from Stockholm. All sorts of people here. And the list kind of goes on and on and on. Oh, thank you very much for your donation. QRP Life. Yeah, I love sharing geology with folks. So it never felt like work. My career and my job, I mean, there's been work, like grading and doing administrative stuff, but the teaching has always just been a pleasure. John from Kansas. Oh boy, let's see if I can say this one. Yurjo from Helsinki. I know I butchered that. Les from St. George, Utah. Kathleen from Arizona. Caroline from Suffolk, UK. Gail from Rochester. Gunatmam from Reno. Sweden is in the house again. Greetings from Motala. Representing. Awesome. Edith, glad you're here. Paul from Glasgow. Sean from Finland. Dave from England. All sorts of people. It's always fun to share where you're from. So, okay. So, we'll get this show started here in a minute. The idea will be to run through a little recap of what happened yesterday, if you're not aware, or maybe you just need a little bit of an update. And then also we'll get into what's been going on since my last live stream last night. So it is top of the hour on my clock. Thanks for joining me today for this live stream broadcast. I am Geology Professor Shawn Willsey. We're going to be focusing on the recent events that have transpired in Iceland, especially yesterday with our 4th eruption. This would be our 3rd eruption of the year, right? I got to think about it. December, January, February. Now we're having our March eruption. Thanks for joining me. Happy St. Patrick's Day. My middle name is Patrick, so that's kind of special. I don't know if it gets much more Irish than Sean Patrick, although I have a little bit of Irish descendant in my background, not a lot, but anyway, okay, let's get started. It is 8 a.m. Mountain Daylight Time, 2 p.m. UTC in Iceland. We're going to do a recap first of the events that took place yesterday, run you through some of the data. We'll take a look at some of the webcams, and then we'll do some question and answer here as we move along. Please follow the instructions from our moderators on how they want to handle the questions. They will aggregate all the questions and then send those to me. We may not be able to get to all your questions, but I will do my best to get to as many as possible. And if you're here for the first time, welcome. There's all sorts of fun geology videos that I put together on this channel, not just related to Iceland, but I do a lot of field-based videos where I go outside, take you to unique geologic locations, and explain what you're seeing and teach those concepts of geology as best I can. In addition to that, we also have these sort of presentation style videos as well. So, okay, and if you're also donating to the channel, much appreciated. Thank you, Terry Brown. That's always helpful. Helps me give the moderators a little something for their time and just helps to build the channel, allow me to get to some of these places and share geology with you. And also, if you can do all the liking and clicking and all the algorithm stuff, that's always helpful as well. So here's a photo from the Coast Guard helicopter of the eruption that occurred yesterday. So you can see just how spectacular this was. This eruption began around 8:30, more or less, last night, Iceland time. It was preceded by some seismic activity, but compared to what we've seen in the past, the seismic activity was highly muted. We did have earthquakes, but they were fairly small, low magnitude quakes, and there wasn't a lot of them. And the best explanation I have for that would be that we have the magma moving through a system that had already been heated up. The rocks had already been stressed and heated such that they were no longer brittle. And so we just did not see this eruption breaking rock and producing seismic signals like we typically do. And I think that's mainly due to the fact that the magma reoccupied the same pathways that it has been using since December. And so that's probably the best explanation for the low magnitude and low frequency of earthquakes that preceded the eruptive event. So let's go to this is probably the best map that's out so far. There's no estimates yet on how much volume of magma or lava was erupted. There's no really accurate flow field map yet, so this is the best one we have. And thanks as always to Amanda Joe for sending me so many great links and lots of information that I can pick and choose from and kind of give this update a little bit of framework. That's always helpful. Much better than me trying to sift my way through all the Icelandic news stations on my own and finding that out. So. But here's probably our best map. So you can see Grindavik down here and the actual fissure, the vent that opened up last night is shown here in the dark red. There's a little segment here. And then there's actually, I believe these, as we saw this taking place on the webcams, these were actually two segments, but they were very close together, just slightly offset. So they've mapped them as one. And as this eruption sort of progressed through the evening, it became apparent that the most alarming and significant flow paths out of this eruptive fissure was this one here that took off towards the west. It did flow over the road, Grindavik. I probably butchered that, but the main road that goes north out of Grindavik towards the capital area and the airport. So it did flow over the road. And was near the berm or the protective lava barrier that had been erected to protect the Blue Lagoon and the power plant. As far as I know so far, it did not compromise the barrier at all. It did cover the road, and I have not heard yet if it covered the pipeline or not. But the pipeline, remember, had been buried after the February 8th eruption, so they had time to make some adjustments to that critical piece of infrastructure. So that pipeline was buried, covered and compacted with soil, and they did that by design so that the next eruption, which happened yesterday, could flow over that and leave those hot and cold water pipelines unaffected. So so when we get the flow field map for this event, which I would assume would come out today, and hopefully it'll come out while we're doing this live stream, that would be great. We should see the extent of how far this lobe or this channel of lava progressed here yesterday. The fissure that opened up yesterday was largely parallel and nearly on top of the one from February of this past year, the February 8th eruption. In the lighter pink color here, you can actually see the extent of the flow field in December. So they've got the December and the February ones more or less merged together here. And I guess they did put in, I'm assuming this darker pink color is actually the lava that the lava from last night's eruption, at least as it was known at that time. The other path of lava that became very important and something that we were definitely taking a close look at was the south end of the fissure produced flows that were headed south. They actually lapped up onto or rode just past the January 14th flow field shown down here. This was the one closest to Grindavik, and this little tiny fissure eruption down here was the one that destroyed 3 homes. And so this thing actually progressed down here. It actually ended up right up against the lava barrier, this berm here. And currently, as it now stands right now, it's about 500 meters from the road or about 1 kilometer from the coastline. And so this lava flow is still technically active. But it has slowed down. It is barely moving at all. It's transitioned into what we call an AA lava flow, where it's very crumbly and there's not a lot of glow. It doesn't look very fluid. The viscosity is really high, so it's very slow moving, just rocks kind of tumbling off the front end of the lava flow. You occasionally see a little bit of glow when it gets exposed. But if the eruption continues to wind down like it is right now, we don't expect this to actually make it to the road unless this thing is sustained quite a bit longer. But as things look right now, it looks like it'll stall and probably end somewhere before the road. Let me show you a couple of webcams here just so you can see what's happening now. So you can see that the fissure is still active. So we still have eruptions occurring along the fissure, but the way these fissures typically work is they start out with I think this thing was about 4 kilometers long, the actual length of the fissure. And when it was erupting last night, we had fire fountains that were shooting up to, I think I heard reports of about 250, maybe 275 meters. That's approaching 950 feet into the air. So they were being propelled. That lava was being jetted up and propelled by the high gas content that was dissolved in it. So lots of pressure built up in the system initially. Starts with a bang, if you will, with lots of fire fountaining, feeding these very hot active flows that were spreading out in all directions. But usually what happens is these fissure systems evolve over time is what we're seeing now. They become concentrated into just a few isolated pockets along the fissure. And then what will happen eventually is we'll just see 1 or 2 of these being active, and this fairly fluid lava like we're seeing here will end up becoming much more sticky and pasty as the eruption winds down. So I would say the eruption's obviously not over. We're still seeing lava erupting at the surface, but I do think it's past its peak. We're on the backside of the curve. It's winding down quite slowly, and possibly by the end of today or within 12 hours or 24 hours, this thing could be officially classified as over. We'll just have to wait and see. So a couple little webcam views here. I did organize the webcams a little bit better today. So there's a view of the fissures looking to probably to the east or to the northeast. Here is another view. This is looking more to the southeast, right along the trend of the fissure. And it looks like it's this central section that's still the most active. The section to the north and the section to the south have largely gone quiet. Here's a nice overview, a little bit of raindrops on the webcam here, but here's Grindavik over here. This black area here in the middle ground is from the January 14th eruption behind the protective berm or barrier. There's the little greenhouse there. Here's the road. And then right here is where this protective barrier, this segment ends, and another segment begins that runs this way off to the south-southeast towards the coastline. Oh, there goes the little drop. There you go, drop. And so the lava flow came down from the left side of the screen and basically impinged upon the January flow field and right near the point here where these 2 segments join. But most of the lava flowed and is flowing still technically down along that barrier to the southeast. There was a secondary channel that you can see off in the distance here, this black tongue of lava here. Those 2 joined together to travel along the flow or the barrier here to form this lava flow lobe. And then you can see where it's sort of terminated here. And it's a little hard to see the road down there, but it's about 500 meters from the road. And then, of course, you can see the ocean beyond, which is a good kilometer or so from the end of the flow field. So that webcam kind of nicely shows that. Let's see what I have here. This one shows... this is back up towards the power plant. So now we're looking at the road that was covered by lava. Now we're looking north this is the power plant. The blue lagoon would be off the screen to the left. And this was the flow lobe that we watched last night advance across this landscape, cover the road, traveling to the west, and then you can see that there. This flow path, as far as we can tell, has also stalled for the most part. It might have just, a very slow, sluggish movement to it, but for all intents and purposes, that's pretty much no longer active. And then this view is really cloudy and blurry, so not super helpful there. So, okay, so what else can we say? So we've kind of given you the overview here, and I'm anxious to see, they should have, I would imagine, the Met Office later today, and it might take, it might be hampered a little bit by the weather conditions, but they should be able to put out, now that it's daylight, they should be able to put out a more accurate map of the flow field from this March 16th eruptive event, now that the lava flows have largely stopped for the most part. And so the flow field is pretty well established. That should come out sometime soon. But this map here from the news agency is pretty good one from MBL. This shows you the big picture and the idea. The orange lines here are those protective barriers or berms that have been built around the Blue Lagoon and the power plant. And then these other sets down here that have been erected for the town of Grindavik. So that's what we know so far. The Met Office update is not particularly insightful, at least this most recent one, but we'll go through it nonetheless. Activity of the volcano has decreased, and this was as of 11:50 a.m. Iceland time, so maybe a couple hours ago. The eruption that started last night between Hagafelt and Stora Stogafelt continues. Activities decreased, now erupting in 3 places, so we've seen the vents have been consolidated into just a few active vents at this point. Almost no seismic activity was recorded after 3 in the morning. We'll get to the earthquakes here in a bit, but it's pretty quiet on the seismometers. The eruption that started at 8:23 last night continues, but as the night went on, the activity on the fissure decreased and now erupts in 3 places. Also, the seismic activity decreased significantly during the night, and almost no seismic activity was measured after 3 in the morning, but then the eruption also subsided. The development's very similar to previous eruption in the Sunnuks crater series. So everything we're seeing here is similar to what we've seen with previous eruptions in terms of the winding down phase of this eruption. Shortly after midnight, lava crossed Grindavikerveg, that's the road north out of Grindavik, and headed towards a hot water pipe from Svartsengi. There's been little movement on that lava tongue since last night and is now about 200 meters from the pipeline. So there we go. So it's 200 meters away from the pipeline, and it's basically not moving at all. So it didn't make it that far. But remember, too, that pipeline has been buried. Another lava tongue flows along the defenses to the east of Grindavik and towards the southern road. So that's that tongue that came south out of the fissure system. That's about 500 meters from the road and maybe 1 kilometer from the ocean. Emergency responders in the area are monitoring the progress of the lava there, but it has moved very slowly. And then they've got I don't know if it's worth opening up, but they've got a blurry map here, well, just with the weather and the rain, that shows, here's, I guess, the 3 parts that, I think the central segment was the one we were looking at on the webcam. There's a little segment here that's still active, and then it looks like there's a couple little spots down here. But I would expect over the course of the day that a couple of these pretty much go quiet, and one of these might continue to pump out lava intermittently throughout the rest of the day. We'll have to see how that goes moving forward. So again, I'd hoped for a much better flow field map from the Met Office. They did last night put out a map that shows the location of the fissure pretty nicely. So this is in red is the location of the fissure, but the purple is not the lava from this eruption. This is from, in deeper purple, that's the December 18th eruption, and the lighter purple color here, that is the February 8th eruption. But you can see that the vent locations were very close to, if not right on, and quite parallel to what we saw for February and the December eruption. And then of course we had that flow lava lobe that came down through this valley, kind of rode up right up against this change in, let me make that a little bit bigger for you, right up against where these two segments of the lava barrier meet. None of the lava, for the most part, or not, I wouldn't say none, but very little lava, if any, flowed along this L7 barrier segment to the west. Most of it was diverted and channeled over here along the L12 and then the L13 flow. And right now, as we're sitting, the end of the lava field is somewhere in here. So it's still a good half a kilometer from the road and a full kilometer or so from the ocean. And as it stands now, I wouldn't expect that it gets there. It's probably not going to get to the road, and it's not going to get to the ocean based on everything that we're seeing here. So that's good news. So I think the overall picture is one of success. The lava barriers have definitely, I think, proven their worth now. This is really the second time they've been tested, the first being the January 14th eruption. January 14th eruption was different because it erupted much further south, and some of the fissure vent that opened up was actually was in the barrier and south of the barrier. Luckily, most of the fissure length was to the north of the barrier, and that's where the lion's share of the lava came out of the fissure, and most of that flowed to the west along the barrier. We did have a couple spots where it spilled over the barrier, especially right by the road, but thankfully that total eruption in terms of volume was pretty low. We did have a secondary vent open up, and we were live streaming, of course, on that day, January 14th, and that unfortunately did destroy 3 homes, and luckily that small segment of the fissure vent was also pretty short-lived. So these barriers are doing a nice job. They're not perfect. We've seen them overtopped. There's, it's not the perfect mitigation measure, but it's quite effective. And I think it's showing its worth here, at least with these first 2 events where it's been tested. We haven't quite seen, we'll have to see when the flow field map comes out. I'm interested to see how much of this flow that came out yesterday and flowed to the west, how much of it actually was along the lava berm or barrier. It didn't get to the pipeline. It was 200 meters back from that. So this is probably the furthest extent of the flow from yesterday, and today is about right here, I would guess. So, okay, let's look at some of the other data here. Let's see what I have for you. Yeah, we'll get to some news stories in a minute. Let's go to the earthquakes first, and then we'll look at the GPS data. We do have some of the GPS data in now that we're a good number of hours beyond the event, and then we can do some questions and answer here at the end and see what questions you folks have. So here is the sequence of earthquakes over the last 24 hours. And so with all these earthquakes here, you can sort of see a well-defined region where the fissure opened between Stora Stogafell, this hill located here, and Hagafelt here. So this cluster of earthquakes here pretty well defines the location of the fissure. Notice if we change this to the last, let's say like 6 hours or so, there's been no earthquake activity, which is to be expected now that this thing's kind of winded down. But what's interesting here is that, that you can almost count those quakes. There's not that many, maybe a couple dozen or so, maybe 30. But compared to some of the other eruptive events that have happened here, this had significantly reduced seismicity associated with it. And the earthquakes only took place maybe within a 30-40 minute window prior to the eruption. So for the most part, this eruption came without a lot of precursor activity like we normally see. And again, I think we'll have to see what some of the analysis is here, but I think that's partially a reflection of how heated the conduits were, how maybe elastic those sections of the crust were, and so they just didn't have the properties necessary to generate earthquakes. To generate earthquakes, you need to have generally rock that is brittle, which usually means it's cool or cold. It's under stress, and then that rock breaks and shifts and moves, and that releases seismic energy. There's your earthquake. And this didn't produce a whole lot of that. So this magma was able to come through these pre-existing pathways that it had occupied previously. The magma that was already in that pathway was probably somewhat not not completely molten, but not completely solidified. It was sort of a sticky, but still able to deform type of medium. And so as this magma from the reservoir was propagating through there, it was able to make headway, move upwards towards the surface without needing to generate a lot of seismic energy and break a lot of rock. That's sort of the way I guess I would put that when it comes to earthquakes. And then we do have a viewer that has put together, and so I want to show this real quick. He just sent this to me this morning. This is Bruce Garner, likes to tinker around on the computer with geology data, which is great because that's probably not my forte. So what he's done here is taken the earthquakes that took place yesterday, and again, there weren't a lot of them, but put them together on a 3D plot with the video here, so you can see this data run yesterday from the 16th of March. What we're looking at here, this is looking, this line here is oriented north-south, so north is in this direction up here where my cursor is, south would be down here. You can see latitude and longitude down here at the bottom of the 3D plot. And then I don't have control over this. This is just a video he sent me, so we'll just watch this. But this shows the earthquakes occurring over time during that period yesterday. So he's got a little tiny cursor up there, if you can see that, where he is adding each hour. So every hour he's adding the earthquakes that are occurring. So that takes you up to, I guess, that's 6 p.m., maybe that's 6 a.m. So it's an animation plot of earthquakes in three-dimensional space, so we can see their depths as well, occurring over time. And so you can see some crude clustering there. There was this little package down here. Yeah, as he rotates it, you can make out that northeast-southwest trend there. So now he's rotated things to vertical, so you're looking straight down. Now he's rotated it back to more of an oblique view, so you can see the depth. And then he's going to play that again, or continue that, I suppose. Let's see. Yeah, now we're at like 5 o'clock yesterday, 6 o'clock, 7 o'clock p.m. And we should see a bunch come in here as we get. Now he's going by 5-minute increments. So 7:15, 7:20, because there's a lot more earthquakes happening in these few minutes leading up to the event. So now we're at 7:35, 7:40, 7:45, 7:50 p.m., 7:55, 8 p.m., 8:05, 8:10, 8:15. You can see a lot of these shallow ones happening here. 8:20, 8:25, and then we're at 8:30. Then the eruptions, it's happening. 8:35. Let's see how far he goes here. 8:40, 8:45, 8:50. Not a lot of earthquakes coming in at this point because the eruption has begun, and he takes that up to about 9 p.m. So great work by Bruce. I thought that was kind of fun to share, and since we're a team approach here, I thought that was really interesting to see. What was interesting to me is that had this been almost any other eruption, if you told me Bruce is going to build the earthquake, a 3D plot of the earthquakes leading up to an eruption of the size of the one we had yesterday, and it was for any other place in the world that has basaltic volcanoes like this, a similar system, you'd probably see, I don't know, 4, 5, 6 times as many earthquakes as what we saw here. So this was a very interesting low seismicity event in terms of the total number of earthquakes that preceded the eruption, which is helpful because as we look forward into the future at what might take place moving forward, we might see the next eruption, if it occurs in the same place more or less, we therefore would expect possibly to see similar behavior, right, where we might not get a lot of earthquake activity that precedes it. The Met Office did put out, they did see those earthquakes. They were low magnitude quakes. There wasn't a lot of them, but they did see them. But by the time they had literally typed up their update, apparently the eruption took place within the next minute or two, which is pretty incredible. So, okay, let's look at the GPS data. So thank you, Bruce, for that. Appreciate that. So what I've got here is our favorite GPS station, but we'll look at some other ones as well. The Svartsengi station, which is probably the station that's most centrally located over the magma body that lies in the subsurface about 5 kilometers down. But I did grab the 4-hour run, so this grabs a data point every 4 hours. And maybe we can update it. Maybe it's got, oh good, so we just got another data point there. So the first plot here is of course north-south movement. So if it's above 0, it's moving towards the north. If it's a downward trend, it's moving to the south. And then you can see time here. So from January to February to March, you can see not much north-south movement. The little steps here represent eruptive events. So there was an eruption here. That was probably the February 8th eruption there. Then there was just slight movement to the north. And then, excuse me, the last little step here at the end would be the events from yesterday. The middle plot shows movement in east-west dimension. So if it's above 0 moving up, it's movement to the east. If it's downward movement, it's to the west. Essentially, no movement at all in an east-west direction. But then there was some eastward motion after the February 8th eruption. Then it didn't move much east-west. And then there was another one here. Oh, wait, this might be the January. Sorry, this is a January 14th probably event here. Oh, no, let me back up. Sorry, this is February 8th. This would be the March 2nd intrusion event. So it did not have much of a signal on the north-south graph, but it did have one on the east-west graph. And then you can see the movement here from yesterday. And then this one's the one that's maybe the most helpful in this case. This is up-down motion. So here we have the area moving up, presumably caused by magma inflating. Magma is being pushed into the subsurface. That heating of the rocks is causing uplift, both by the magma occupying more volume and the fact that you're heating up rocks at least at depth. And so here is the February 8th eruption. And so the GPS station dropped back down. This is what we call deflation. And because we had taken some of that magma had spilled out onto the ground, so there was deflation. Then it resumed inflation, started rising. Probably a little bit of a blip right here for the March 2nd event. But then you can see pretty steady increase. And then here's our data points from the eruption yesterday. So if we kind of zoom in there and look at exactly what took place yesterday, you can see, you know, this data point here probably represents a GPS measurement that was taken during the eruption, but it had not dropped as much because there was still lava and magma being erupted. And then you can see the last 3 points here over the last, this would be 12-hour period, I suppose. These are all clustering at this lower level here. What's interesting is that it's dropping down to a level that's pretty much on par with the highest elevation it reached before the February 8th eruption. So, and we've seen that over time, if we go to some of the other plots, is that these things rise and fall, kind of a sawtooth pattern, if you will, and then they rise and they fall, but there's an overall upward progression. So as this system has these eruptions and these inflation-deflation cycles, it's making the rocks at depth hotter and more buoyant, but also more elastic. The ground is able to deform and recover more than previously. It's like each event increases the elasticity of the crust to some degree, because every time we get to our breaking point where the eruption is, it's always higher than the previous one. If we could see the January and December eruptions that are off the graph here to the left, you would see this pattern continue, right? You would see that this point here, February 8th, is higher than the threshold that was reached for the January 14th eruption, which was maybe somewhere down here like this. So we can see the GPS signal coming through here. Let's look at maybe another station or two, and let's stay with the 4-hour runs, because those are, I think, most insightful. This is the one we just looked at. Excuse me. But we could also look at, so here's Elvarp. This is a station off to the west. So we can see that the eruption yesterday moved it to the north, similar to the progression in what we see with the February 8th eruption. And it also moved the station westward, which again is what we saw, or excuse me, eastward, which is again what we saw on the February 8th eruption. So this is the GPS station moving westward, presumably because if you think of it like a balloon, this station's kind of on the margin of the balloon, so it's being pushed to the west. But then when it erupts, it's able to shift back towards the east because as the ground drops, it's also shifting things laterally. As we have inflation, that's more expansion, so things are moving away. And when we have deflation, that's more contraction and things moving back towards that center point of the magma system. So you can see the same pattern here, right? So then we have westward movement over time, and then there's our trend upward during the eruption. So we're coming back to more or less the same point we were at for the February eruption. And then we look at the uplift data, it's a similar trend. So uplift, inflation, February 8th, eruption, deflation, resuming inflation through the rest of February into March. You can see there's little lulls here. There's little places where it's not moving upwards as quickly. The slope is changing over time, but you could fit a line through here if you needed to. And then deflation. And our deflation here has taken us back down, maybe in this case a little bit lower than what we needed to get to for the February 8th eruptions. Let's maybe look at one more. We can geek out on the GPS data. This is why people come to the internet, right? Is to look at graphs. Some of us love graphs, I know it. Let's see. Which one should we go to? They don't have the Blue Lagoon site doesn't have a 4-hour run. Well, they all pretty much show the same thing, but I told you I'd show you another one. So let's look at this one here. This is Thorbjorn. So this is the hill right here. So this is the GPS station located on this mountain, this hill, just north of Grindavik. And north-south data, pretty similar, right? So not much of a trend, but slight southward movement. Eruption February 8th, a little bit of movement to the north. And then again yesterday, and it looks like it's similar in terms of magnitude, right? So the amount of movement to the north is pretty similar. East-west movement, pretty similar again. Here's our February 8th eruption. This is our March 2nd intrusion, which was not an eruption, but it was still magma leaving the system. And then our eruption yesterday, and then the up-down movement. And so again, it looks like that data has come down to a point, and it could continue to drop. We're not sure. It's still erupting, so I would expect these to drop a little bit further. As long as lava is coming out of the ground, these should drop a little bit. But I don't expect it to drop, tens of millimeters between now and when this thing's over. So it should stabilize here soon, but it's pretty close to being on par with the elevations measured prior to the February 8th eruption. So, okay, so that's the GPS data. Let me give you guys a nice, satisfying view of something there, and then give me just a second to look at. I got a couple pings in my ears here whenever Amanda Jo sends me a message. So let's see what she's sent me here. She sent me some news articles. I suppose we could digest these together in real time. All right, I'm going to throw this one up. This one made me chuckle. Remember, these are all Google Translate, so it's taking Icelandic news stories and then doing its best to translate it into English. And the title of this article is "Now Everything is Well Lubricated." So this is Arman Holskotsson, one of their scientists there. The eruption centers at Grindavik has become well lubricated, and that largely explains how little warning there was of the eruption last night. It looks like the eruption will end in the evening, but they will probably resume waiting for the next eruption. Let's see. He said, among other things, activity is now mostly in the southern part of the fissure, while one smaller crater is active in the north. It's greatly reduced the eruption since the beginning. He said the volcano was, quote, well lubricated. And probably if we were taking that into English, we might use different phrases there. But I think I know what he's saying, that the system is primed or easily it's a system that's very easy to generate eruptions. The advantage is if this happens in the wilderness, even though the lava flows down, it gives people reaction times. Yeah, fortunately, part of the gardens had come up from the south. I think those are the defensive walls. I think that's the translation for that there. The eruption could end tonight. The power of the eruption has been greatly reduced. Ooh, here he says, then we reload the gun. Yeah, so as soon as this thing's over, presumably we have no evidence to suggest that the magma is not continuing to move up from a deeper source into the shallow magma body that's near or underneath the power plant region. And so presumably you've just erupted not all the magma from that system, but the eruptible magma, the magma that was under pressure, had a lot of trapped gases in it. That's what came out yesterday. We still have magma residing in the subsurface, and as more comes into it, that's just going to reset the clock, so to speak. Let's see, anything else here? Yeah, so here he is saying again, scientists have said it's possible these particular earthquakes could end in the fall. I don't know what basis, I mean, it could, but I don't know. I'm not ready to make that kind of forecast or prediction. The system, we should assume the system is going to continue until we have evidence to suggest the system is slowing down. He said, however, that does not mean the situation in Reykjanes will be over. Instead, it's believed that earthquakes move to the west, possibly to Eldvorp. And he's the one that's been really stressing this area off to the west, that eventually he thinks that the eruptions are going to end up there. And he might be right. I just don't know what evidence he's using to come to that conclusion. So there's a quick little news item sent to me by Amanda Joe. Let's see what else she says to me. The lava that flows towards the road does not cross quickly. The lava continues, and how they try to monitor how fast it goes. Sorry, I'm just reading this and trying to... At noon, it was estimated the lava would have to travel, about 500 meters to reach the road. And it doesn't seem to be moving fast enough to get there. So... and then she sends me one more link. So we're going to come to you viewers in a second for questions. Let me just see what she sent me here and see if this is... Yeah, it's kind of cloudy right now. So the webcams, with the kind of wet, stormy weather kind of on and off, the webcams aren't... Not all of them are awesome right now. So... Okay, Amanda Joe, I think I caught up to your last update that you sent me. So let's take a few minutes now and answer some questions from the viewers. And I haven't been paying attention to the live chat while I was just kind of updating you there. But it looks like Carrie Knight, MNMK, SCH737, and shoot, one other person I can't see there. Thank you for your... Turner Rents, Rania J. Adams Ramstead. Yeah, thanks for all those that are donating to the channel. Janet Purdy, Carrie R., Turner Rents, Sandy SR. Hopefully I'm giving everyone a proper shout out here. Meta Jetta, thank you for all your kind donations to what we do here, where we just try to share geology. Okay, let me go to my email and see if I have... Awesome. Susan already has a list of questions ready to go for me. So let's just go through these one at a time. We can put the questions up here if that's helpful. Make that a little bit bigger. All right, from Robert Seacrest. Estimate of duration of this overall eruptive cycle, decades or longer? I don't know. I have no idea. I mean, all we have to go on is what's happened in the past, and we have only 2 data points in the past. So maybe it's worthwhile, if I can find this really quick, bringing up a graphic that might help you as we sort of form this discussion here. Here we go. So how long will this event last? Oh, that's not what I wanted. Let me find the right one. Get organized. Get organized. Is it this one? Oh, here we go. Eruptive history. Okay, so we are looking at, for the most part, it doesn't even matter which system we look at here on the Reykjanes Peninsula because there are some commonalities here. So the yellow bars show periods of volcanic eruptions based on the rock record. So by taking lava flows, volcanic features in the region, assessing their ages using probably most likely carbon dating. So when an eruption occurs, if it flows around some vegetation or a tree, it can produce charcoal. That charcoal can then be dated, and so you can figure out the age of the eruption. So notice our time scale goes back to about 4,000 years. All the rocks that are older than that are covered, not exposed, inaccessible. So there was a period of eruptive activity from about, 3,100 to 3,500 years ago that affected some of these volcanic systems. Now, they've been defined as systems, but there's good reason to think that they somewhat behave all in concert together, that perhaps they all are a little bit connected. So you can see that these coincided a little bit here. Now there's question marks here because we don't know exactly how long that lasted. The carbon dating is the red lines here, so that's where we have some hard, fast data. Then there's periods of quiescence where there are no eruptions, as far as we know, in that region. Then you can see there was another eruptive period from about maybe 1,900 years ago to about 2,500 years ago that affected most of these regions here. Then there was another quiet period of several hundred years to maybe over 1,000 years. And then the most recent one goes from about 800 years to 1,200 years. So there was a more or less 400-year period of volcanic activity. And then there was a quiet period. And just now, in the last 4 years, we've begun, most likely, a new eruptive cycle. So if this data is good, and if these 3 cycles of activity, if you will, are good indicators, we're likely to see a lot of future eruptions on the Reykjanes Peninsula moving forward. Doesn't always have to be this system, and in fact, we know that we're not in the same place we were a year ago. A year ago, all the volcanic activity was further east at the Fagradalsfjall area, and now it's shifted to the west to this Svartsengi area around the power plant, which is unfortunate because there's a power plant, the #1 tourist attraction, and a town right there. So of all the systems to become active, this one maybe is the worst. You could argue that the northern end of like the Krishuvik system would be bad for the capital area. But to answer your question, it's hard to say. I think we just have to kind of see what happens. Clearly, we have a system that is generating and transporting magma up towards the surface, and there's no reason to believe that's going to end anytime soon. And so I think Iceland has taken a good approach in that they are looking closely at how they might envision their towns and infrastructure and way of life moving forward. Like what will the new Reykjanes look like in terms of what's open, what's not open, how we manage it. And I think they're doing the best they can to kind of react to the situation, but also be a little bit proactive like they are with these lava barriers. So great question, and one that I wish I had a good answer to. Tim pointing, there was talk of the only road out of Grindavik maybe closing due to cracking. Did the lava reach the road east of town? No, so I think that's the, this road here. The lava did not reach this road east of town. It's right about here, I would guess. And it's slowed down. It's moving very sluggishly. And based on everything I'm seeing, I'm not expecting it to reach the road this time. But the next eruption could be, a month or so away. And depending on where that vent opens up and how much lava is erupted, that could change. So But what I think Iceland's shown the ability to do is they reestablished this roadway. I mean, this thing was covered by lava on February 8th, and within just a few days, they'd reestablished the roadway back over that. And so that may be part of the new normal in this area is just, it might become commonplace, right? Like, oh, we just had another eruption. What are you doing today? I got to go out and put a road in over the lava. Oh, okay, well, I'm going to go fishing for the day. Like that, it may become just this commonplace sequence of events and tasks that they have to, just routine maintenance that they have to do in order to keep these roadways and the infrastructure open. So, okay, from Marrow, how long does it take? Oh, wait, I skipped a question. Peter Newton, do you think that the berms will break or be overtopped? Well, we've seen that they can be overtopped. In terms of break, I think it would take an exceptionally fortuitous set of circumstances in order to actually break one. I think it's more likely they get overtopped depending on exactly what takes place. So if you mean broken by a fissure, well, yeah, we saw that in January. That thing ripped open right through part of that berm that had been erected there. That's where all this lava came from here. Luckily, this was the more productive part of the fissure, and the topography helped too, and a lot of that lava ended up flowing along that. But we did see part of it breach the fissure or breach the berm here, and then maybe a little bit down here. That my diagram may not be perfect there. So, but we've seen it in the past. So they're not foolproof structures. There's no guarantees with them. But in terms of guiding 80, 90%, or hopefully more of the lava into areas where it won't be a problem, it seems to be doing okay. We've really only tested this twice now. There's been 2 eruptions that really put this to the test. And so it'll be interesting to see moving forward. But we have to expect there will be failures, right? We have to expect that there might be situations and circumstances where the lava can overtop the barriers or possibly compromise them. From Marrow, how long does it take for the different types of moss to grow again? Can you use them to make a timeline or estimate when an eruption has occurred? That's a great question. I'm no botanist. The mosses are one of the first, what we call, what's the right word? Colonizing species to come into an area. So once you have this black lava landscape just covering everything, completely devoid of life and vegetation, the lichen and the mosses, as far as I know, are some of the first colonizing species that can kind of take root, if you will, or grow on the surface. And I don't know, it would seem that you could possibly use them as a rough guide. Like if we have 2 lava flows that are old, like hundreds of years old, but we don't know exactly how old they are, and one has much thicker, more evolved, mature moss, and one is thinner, you could probably play the this is older than that one game, but I don't know how precise you could be with getting good resolution on those ages. So it's a great idea, and I'm sure someone's probably looked at it or worked it out. I just don't know off the top of my head I don't have any knowledge to that in that realm. Camille Dion West, if the lava made it to the ocean, would the black sand produced end up impacting the harbor? No, I don't think so. You would end up with lava ocean interaction here. It would be somewhat locally explosive. It would fragment the lava, and it would produce some, I guess you could call black sand. But from what I know with the ocean currents here, a lot of this is just coming straight in off the ocean. I don't think there's any significant longshore drift. So you'd have to somehow transport that material around this point and into the harbor and past these jetties here. And I just don't think that would be very likely. So I think most of the broken, fragmented material that might be created at an ocean entry would stay pretty close to that area. And so the idea we talked about yesterday is you could build out, depending on if this lava, and right now it looks like it's slowing and stopping, so this is not happening. But if it were to continue, you'd build out a lava delta. So it'd actually be a delta of lava built out into the ocean as it builds up from the bottom up. and then kind of swings back and forth across the area. Very similar to a river, although a little bit different because it's the the behaviors are a little bit different there. So okay, Quark Tar. Is it possible to have a halfway serious guess on how long we might keep this monthly rhythm? Is it here to stay, or will it wind down, or no estimate possible yet? Yeah, I don't think we can tell. There's no way. There's no crystal ball. There's no way to look and see what's going to happen. All we know is that that deeper magma supply, which began, I guess, in October or so of this year, it doesn't show any signs of slowing or stopping yet. And so as long as that magma supply continues to rise, then this would continue. And right now, I mean, the system, it's not quite a rhythm, I'd say, but and because small things change with every eruption, every intrusion. But we've had 2 intrusions and 4 eruptions, right? Over that time period. Hard to say. It's no, not. We really can't make any predictions as to when it will wind down. I know we talked at one of the previous updates about there was 2 scientists that thought this was going to end by midsummer, like mid-July or something. And I'm interested to see how yesterday's eruption as a data point plots onto their linear extrapolation of the data. They took the last 4 eruptions or so, plotted them up in terms of volume, if I'm remembering this right, and then just took that it wasn't even a linear trend in the data, but they put a linear trend to it, and then saw when that might get to 0, and it reached 0 in mid-July-ish, and so they made some projections that it could be over by then, which I don't agree with. They could be right, but I don't think you can put a linear extrapolation on this system. From JZ, I simply accepted the material gets erupted over 100 meters higher into the air. As the material is not the lightest, my question is, what is the pressure that the lava is subjected to underground? Trying to understand this question. So the material that gets erupted, that gets shot into the sky, is incredibly gas rich. If I caught one of those pieces, first of all, it'd be very hot, but if I could catch it and not burn my hands and handed that to you once it had cooled off, you would see a very porous rock with lots of gas bubbles, what we call vesicles. But trying to look at that material and then project that into gas pressure that's underground, I don't have good expertise on how that's done. And I'm not sure you can. I think I know what you're trying to do. You're trying to say, hey, it's shooting stuff into the sky 100 meters or so. So can we figure out the subsurface pressure from the jetting that's occurring into the atmosphere? And you probably could do some really rough estimates and calculations, but it probably would not be very precise or accurate, would be my guess. You have to remember, too, that a lot of it depends on the conduit that lava is coming out of. So if it's coming out of a narrower space, it is going to propel that material higher into the air because you're getting a nozzle effect, right? Versus if it's just opening up a 3-meter wide fracture that runs for 2 kilometers, that lava might not shoot up as high. It might just pour out onto the ground more passively. Queen Moltz, is there a way to see any imagery of what intrusions, tunnels, or flows run under the surface of any volcano? Not usually, because the intrusions tend to be fairly narrow. The tunnels, I'm not aware of any reliable geophysical methods. We can image the magma body with seismic waves and gravity instruments, gravity measurements. We can image the bigger body that's down 5 kilometers, but the actual pathways that the magma is taking to make its way to the surface, the best thing we have there is the earthquakes and where they're occurring. And sometimes the GPS and the ground deformation can help a little bit with that too, but not getting a clear picture like a as-built, plumbing map or something like that. Rock Tapper Robin, the linear volcanic zones in the Reykjanes Peninsula all seem to lie between the hills or tuyas. Has anyone dated Thorbjorn or other subglacial volcanoes? Okay, so that's a good question. The volcanic zones aren't in between, although this one looks like it is because you've got these hills here. Let's get rid of a couple things here, the berms, and let's just take these out too. There we go. So it does look like these are coming up through the valleys. I mean, you are right that the topography here, the higher and steeper ground in this part of the Reykjanes is mainly subglacial volcanic features. And so those things erupted, thousands of years ago. I don't know if they've been dated, so that's a good question. A lot of the stuff that comes out of these is very fragmented. It's altered by water because the glacier is interacting, volcano is interacting with the ice, which is melting into water, and some of those interactions change the things that we would use to date the eruption. And so it's very tricky, the way I understand it, to date some of these subglacial Tindar or Tuya eruptions. And so what we generally do is just look for relationships, like relative dating relationships, like this is older than that, that's older than this, but we know how old this is, so therefore, kind of working your way backwards that way. So these are all, you can also see too on Thorbjorn in particular, it actually is cut by two sets. It has a little graben at the summit, so there's two sets of northeast, southwest trending faults that run right along its crest, which are clearly younger than the subglacial material that formed this volcano, this mountain. And so, but have they actually been dated? Yeah, I don't know. I don't know if there's a good hard date for that. I could probably look it up. I want to say that I read, when were the glaciers on the Reykjanes last? I think it was something like 6 to 8 to maybe 10,000 years ago. So that's probably a pretty good ballpark number, but don't quote me on that. So really good question there. Wildly Heather, I saw in another stream that people were collecting lava samples. What are they looking for and what will it tell us? Yeah, so at the leading edge of those lava flows, scientists will often collect samples. So they'll get something, poke the lava with a not necessarily a stick, but they're rock hammers or a metal rod, grab a lava sample and immediately quench it. So put it in a bucket of water so it cools and solidifies quickly. And then by taking that back to the lab, you can look at the chemistry and the crystals in that lava under a very high-powered microscope. You can basically take that chunk of rock, cut it down into a very thin sheet. It's called a thin section. So thin that light actually passes through it. And you can see what the crystals are like. So they're probably looking at a couple things. One, they can just look at the geochemistry. So they can just crush the rock sample down and see what it's made out of chemically. Two, they can look to see how those individual tiny little crystals in the lava, what they can tell us about its ascent from the subsurface towards the surface. A lot of times as magma is rising, it can sometimes stop and reside in a place for a little while. And depending on its depth and temperature, those crystals sometimes will grow. So they'll get little concentric rings called zoning around them. And so you can actually see the growth and you can interpret the growth of the crystals to reflect how long it took the magma to rise and maybe to some degree how long it resided at different levels in the crust coming upwards. So those are just some of the things that they look at. Peter Hagen, can rock be annealed as iron and copper can so that bending is easier? Like annealed, yeah, I don't know exactly. Does that mean like bent? Yeah, obviously if it's hot, it's more elastic. It's able to bend without breaking. So yeah, I'm not sure I understand the whole question there. Sorry about that. Mitch Ashdown, how deep does the degasification start, or is it just right at the surface? Well, the gases are trapped in the magma. As they get closer to the surface, those gases will come out of solution because there's less pressure on them. So as that magma is rising from depth, that gas is under pressure, but as it gets closer, there's less pressure on it, so it starts to form bubbles in the magma. The bubbles take up more volume. So that's how you get such a dramatic nozzle effect and the fountaining and the lava being shot out of the vent is that it's partly that degasification process. It's similar to, you take your soda bottle, shake it up, and when you unscrew the cap, you're reducing the pressure inside the container, and that allows the dissolved gases in your soda to actually expand and rise. And that's why, if you shake up a bottle of soda and then unscrew it, you can end up with a sticky, syrupy mess everywhere. Let's see. Optimus Clang, with multiple eruptions along the same fissure, I'd love to know if anyone has measured the topographical changes in the area due to lava, particularly the elevation. Yeah, that would be interesting to know. And I don't know that they're doing that per se, maybe because these eruptions are happening in such rapid succession. But the idea would be, at this point here, we're going to end up with patches of ground that have been covered by lava 3 times, right? December, February, and now again here in March. And so how much has each eruption built up the land as it's put new lava at the surface? And then when you put another eruption on top of that, so it's changing the topography, right? The map that we might have used for this area back in November has changed because this lava flow is building up the land higher. So high places maybe now are lower and low places are now high, because a lot of this lava filled in the low places. That's where it would have flowed to, but now it's built up that land to a little bit higher degree. So I don't know if the Met Office or someone else is doing like detailed surveys between each eruptive event. Probably not, because you'd have to go out there onto those still kind of hot, not completely solidified, still degassing volcanic gases. But maybe you can do it remotely with satellite imagery. Not sure. Peter Newton, I think we answered that one about your question was up there about the berms being overtopped or broken. Boy, a lot of questions on this one. Grandma Plays, can you explain that it is annoying to tell about other streamers being active? People complaining about mods being too strict. People don't know you can't share other streams without permission. Yeah, so I think what they might be talking about there is I fully know that Isaac, I can't remember his last name, Finnbogason, is an Icelandic gentleman who does great work with his drones, and I was actually watching some of his stuff before I got on the live stream here with you guys. But what I've learned sort of in this world of YouTube and live streaming and stuff, things I didn't really know, that's just being naive, is I can't show his stuff. So I can talk about his streams. I can tell you to go watch his stuff if you want to. But the second I take his live stream images and show them on the screen for you guys, then that's a copyright infringement. So I don't know if that's what you're asking. I think while we're here on the Shawn Willsey YouTube channel with our great geology community, you can certainly point people to other sites, and I don't particularly care because there's lots of good stuff out there. But yeah, I can't pull up Isaac's live stream while I'm running a live stream and show it, because then you're watching it through mine and he's not getting the people onto his. And I totally understand why. And I would feel the same way if I was him, right? It would make me upset if someone took one of my videos that I spent time and effort putting together, they showed it on their YouTube channel, and were using it as content or to take credit or whatever. So I don't know. It's a weird world. I don't understand how it all works, but there you go. Back to geology. Buzz Keto, what would happen had the lava flow reached the water? So we talked about that a little bit last night. So let's throw the berm back up there. So had this flow, which we now know is stagnated and probably largely stopped. I mean, it might be very slowly moving forward at like, a meter every hour or something. I don't know but it's basically stopped here. Had that made its way out to the coast, we would have had a locally dangerous situation. So basically, you wouldn't want to be, within several hundred meters of this zone. As that lava interacts with the seawater, it can produce some sulfuric gases and aerosols that can fall out of the sky. As the lava is quenched by the cold ocean water, the outside develops a rine, but the rest of the lava interior is still hot, and so it can be explosive, and it can fragment and shatter the lava. Now, that's what I'm not saying is it's not a volcano exploding, right? It's not like a Mount St. Helens thing. It's just locally explosive, so it can throw stuff up into the sky. Ash and pieces of rock can fall down to the ground around it. And then slowly that lava will build the land outward. So this is the way islands like Hawaii or Iceland add real estate, is if you can get the lava down on the coastline, if you have enough lava erupting, you can build the coastline outward and add real estate to your area. So it would have built out a lava delta had the lava continued. It wouldn't have been like way out here, like out into, a kilometer out from the ocean, but it probably would have built out something, maybe a couple hundred meters. And you can go to places like Hawaii and see where that happened. Maybe we'll do that real quick. Let's do a quick little tangent here, team. Let's zip over to Hawaii, and let me show you what that would look like. So here's Hawaii, and you can see all this new real estate that was added here. But let me show you what it looked like before. So let's find a nice, good image. This was in 2018 when this happened. Okay, so here we are, 2016. Let's get our view just perfect here. Okay. So here's Kapoho Bay. You can see some of the houses here. But more importantly, what I want you to watch is like what happens to the coastline here from 2016 to today. Do you see how much it went out? So here it is again, 2016. There you go. Okay, and now I'm just going to hit 2023. So especially like this little section here, you'll see how much further pronounced it is there. So you added maybe, I don't know, a couple hundred meters maybe of coastline there. So interesting. Good stuff. Okay, last question from Camille Dion West. In Hawaii, there has to be no lava for a month or so before an eruption is declared over. Otherwise, it's a pause. In Iceland, it seemed that an eruption is over as soon as there is no red. Why? Don't know. I don't know. I don't know myself for sure that is the rule in Hawaii. You might be correct there. That I think it's not just lava on the ground. I think it's other signs and indicators. It could be seismic signals, could be other things that show that the eruption is still taking place. I mean, you could easily say that the whole area has not been over, that we started an eruption in December and it's still going, right? I mean, you could sort of spin it that way, that you've just had these eruptive pulses and these pauses in between, I suppose. So it's just kind of how you define it, semantics and stuff, I suppose. So, okay, let me see what's going on elsewhere. Let's maybe check back in with some of the webcams. So it looks like those fissures are still erupting. And they're occasionally throwing some of these clots of lava, maybe hard to get scale there, but maybe up to 100 meters or so. Not nearly as high as they were last night, but you can see some. So that's all the gases, right? The magma is still hot and fluid. The gases are still propelling the lava out of the vent. Check a couple of the other webcams. So there's that section of fissures. We saw those. Yeah, we're not going to see anything glowing here. Now, if this was nighttime, you might see a few little orange spots here and there. But with this being daytime, you're just not going to see anything, especially from that sort of distance. Power plant. Yeah, it doesn't look like much is happening there either. A little hard to tell. They might be, I don't know if that's, they might already, are they already trying to reestablish the road over, or the roadway there? I can't tell. There was just a few little, I can't tell if that's little steam plumes and just heat spots. That's probably what it is. That makes more sense than equipment. A little hard to see. And then that webcam's not super helpful. Let's see. I think I can do a few more questions. Looks like the second packet just came through. Let me see how long it is. I do have some other things to get to. Yeah, I think we can get through this last one. This will probably be it, though, for questions. I appreciate everyone who has sent in questions, folks that are still here watching and learning with me. That's great. And so let's run through this last segment of questions, and then we'll see if there's anything pressing. A couple things came through from Amanda Joe. Let's see. We read that the lava travels about 20 meters per hour. The speed of the lava flow towards the south road has decreased significantly since yesterday. It's crawling lazily towards the road, according to a reporter who's at the edge of the lava. We calculate lava creeping forward about 20 meters per hour. Therefore, it's not at all certain that it'll reach either the south road or the sea. It's also been stated, this is from Amanda Joe, that the lava that flowed to the west over the Grindavik road has stopped and did not reach the pipeline. So that further northern flow lobe that came across the road north of the power plant in the Blue Lagoon, it sounds like that one has completely stopped. So it's not being fed by any eruptive activity. And that makes sense when you consider that I think the part of the fissure that's still active is this section in here, and this northern section is pretty much done erupting. So the way these lava flows work is, the further they advance down slope, down gradient, it requires, a consistent supply and a sustained supply of lava. So if the supply of lava wanes here, it's a deal breaker. You can't get the lava to progress and advance. So there's kind of a balancing act between how much lava is enough lava to continue to advance the channel and the lobe. And down here at this south end, there's just enough that it's just creeping forward, but at a very, very slow rate. So thanks for the update there, Amanda Joe. Let me get a quick little sip of water, and then we'll bust through these last section of questions. Let's see here. All right. I'll do my best on these. Let's see. So we've got Sean Muller. In case the pipe again gets damaged, can you explain why in Iceland they can make a new road after just about 24 hours, whereas on La Palma the government stated that 4 months was the minimum? I can't speak to that. That's two different government bodies, and the La Palma eruptions, there could be some small differences in viscosity. I don't know much of. I watched the Canary Islands eruptions a little bit and thought it was fascinating, but I don't know a lot about it scientifically. Could be the case where La Palma didn't. There's not a lot of eruptions that happen there, and in Iceland it's like we got to get roads back open because we've got this little lull between these eruptions that seem to be coming every 3 to 4 weeks. So I couldn't say. I don't think it's. I don't know if it's necessarily a lava cooling type of issue versus just being willing and able to just get it done. So could be too the thickness of the flow. That lava flow that came across the road by the Blue Lagoon in February and I think yesterday wasn't very thick. It was a fairly small flow in the world of lava flows. And so therefore it has and retained a lot less heat. So once it was cool at the surface, and you probably do a little bit of testing to make sure you can drive over it, then it's probably good to go. Maybe in La Palma, I don't know, we had thicker flows that took a lot longer to cool. So not sure. From Wolf Argent, isn't even 4,000 years a blink of an eye compared to the age of the Earth? Sure. Yeah, I think he's going back to, yeah, so these last eruptions on the Reykjanes were very recently geologically. 4,000 years. This is, even if you went back 2 years ago, well, I guess it'd have to be 5 years ago when nothing was happening in this area. I hope most geologists would recognize, based on the rock record and the evidence there, that this was still a potentially active system. It's on a plate boundary. Your last eruptions are only 800 to 1200 years ago. Usually to classify an eruption as at least inactive, I suppose is the word. Usually it's got to be several thousand years of inactivity to give it that label. And then again, it's just labels. It's not even, nothing hard fast about that. DC Hammer 07, as well as barriers, is the earth removed to create, then creating significant channels down which the lava flows, or is that really not significant? As well as barriers, is the earth removed to create? Yeah, so I think what happened when I've seen some of the imagery from those barriers, especially those ones further south where that southern flow is, they've actually scraped up one side of the ground and then piled it up to create the berm. So they're actually sort of creating a high barrier, but then scraping and removing some material next to it. So they are somewhat creating a channel as well. So they're not just creating a impediment to lava movement, but they're actually creating a bit of a low area to channelize it and have it carry downward. Hopefully that was what you were asking about. From Al Brussel, did the Grabens form before the first eruptions, creating weak points? Can't remember the timeline. If so, would we expect widening to the west near Eldvorp as a precursor for activity switching to the west? So I have to remember the timeline too. We had the Graben created around November 10th, and I guess we can pull these. Oh, now we got to go back to Iceland. That's okay. We wanted to go there anyway. Take out the berms and add the Grabens. So if I remember the timeline right, there we go. This western one, the teal green color here, that was from the December event. And then the blue one here was January, I think. So clearly, regardless of the timeline, when you're creating structures, pathways, fractures, you are creating weak points. And so if so, would we expect widening to the west near Eldvorp as a precursor for activity switching to the west? Well, I think the point is nothing's going on over here. Like there's just, there is, the crust is reacting. We have a GPS station that's tracking the movement over here where the magma body is. But we're seeing no earthquakes at all. So the earthquakes are going to track where the deformation is. The earthquakes are going to track where the grabens and the fractures are forming. And we have seen no earthquakes here at all that I remember. And so until we get earthquakes in this region, I just don't consider it, a point of discussion until we get something happening over here that suggests we might have eruptions occurring in this region. And I don't know if they're just basing the past, there was an eruption here. We can see that chain of craters kind of running through the landscape here from 1200 years ago. You can see that lava flow right there. But now, currently, there's nothing to suggest that the magma is going to move in that direction. It's got these great pathways over into this area, and it seems like it's going to continue. So until we see that, I don't, it's like saying, why pick that direction? Why not pick, why up here? You could get some cracks up here or any other location. So there are fractures there at the surface, but we don't know if those fractures extend down deeply and can be connected to the magma body. So that's sort of my take on that. Next question. Jeremy Potter, why are there quiet periods in the eruptive history? Isn't the plate always generating magma? Good question. Yeah, so I think the idea is that there's, that there's maybe episodic movement of the plate boundary. I don't think the plate boundary, it's not always generating magma and it's not always moving. So when we say things like the plate is moving 5 centimeters each year, that doesn't mean every year it moves 5 centimeters like clockwork. That means on average, and your average could be based over a long period, it's moving 5 centimeters per year, which means it could not move for 10 years. And then in 1 year, it moves 50 centimeters or something. So it seems to be episodic in nature. But again, we're only looking at 3 events. So it's almost like, I think it runs, in some respects, it's the same, what's the right word? It's the same trap that a lot of people, I think, run into with Yellowstone. They say, well, there was an eruption 640,000 years ago, 1.3 million years ago, and 2.1 million years ago. And they take the average time between those eruptive events and then they project it forward and say, well, we're overdue for an eruption because it erupts every 600,000 years or whatever your number is. And that's just bad math. That's bad statistics. There's nothing that suggests that it needs to be that cyclical. So, okay, geology nuts. Are there any rock records of longer sustained eruptions from previous eruptive periods? In Iceland or elsewhere? Certainly elsewhere. Hawaii, Kilauea erupted from one vent at Pu'uo'o from 1983 to 2018. So that's 35 years and it was erupting lava every day for 35 years. Lava was being erupted for that entire period. So yeah. In Iceland, I'd have to look at the literature, not off the top of my head. Definitely, a lot of the eruptions have lasted a lot longer. These eruptions have been incredibly short-lived. These 24 hours, 48-hour periods seem to be quite short-lived. From Fennigan, has any consideration been given to monitoring land movement and inflation near the eruptive breakout that destroyed the houses and or further southwest along the fault? I think they have, so I think you're referring to this area here. I think there are several GPS stations in town. So there's one here, there's one here. I don't necessarily have them all. This is just the ones I've added. There's one over here. So they've got 2 right in town. I don't know that they feel like that it would be necessary to put one, right by the vent that opened up here. I guess you're talking about this area here. These are pretty close and should capture any sort of movement there. So yeah, I think, if there's going to be land movement and inflation in that area, you have enough spacing on your GPS system, your ground deformation system, to detect that. And once we get past winter months and the snow's no longer on the ground, they should be able to use a little more INSAR data, satellite imagery from above, to detect some of the ground deformation. So, but right now with the snow on and off, it's not a good use of that tool. Okay, next question. Marin Angeli, could this region ever produce a Siberian Traps magnitude eruption? Probably not. The Siberian Traps was a big volcanic outpouring about 250 million years ago at the end of the Permian. We think it at least had a role to play in the big extinction event at the end of the Permian. We're not sure. There's somewhat division and debate over how much of that eruption produced that extinction event. Here, I don't think so. I'd give it, a 0.01% chance that you could have something that big. Remember too that the bigger event, and this is true for anything in earth science, the bigger the event or the bigger the magnitude, the less frequent it occurs. So looking at a huge event that happened 250 million years ago and was nearly unrivaled in terms of its extent and magnitude, to think that we could get something like that here, I think is just not quite possible. So, But an interesting question, and we always like to think about some of those fun, big events in Earth's history. From Sorters, in the older eruption cycles, how much lava was deposited every year of those periods? I think he's thinking about my graphic I showed with the eruptive history on the Reykjanes. How much lava was deposited? I don't know in terms of like thickness. I don't have that data in front of me. I don't know. Or volume of lava. I don't know. Yeah, that would be interesting to look at. That data may exist, at least as a crude estimate. Certainly the most recent one, you can measure the extent of the lava on the surface. If you can get a handle on the thickness, either through borehole data or outcrops, then you could calculate volume. Probably not getting a lot on the ground though. This is a brand new landscape. There's no big deep canyons that have cut through this landscape. There's no flowing water. There's no rivers or streams on the Reykjanes Peninsula. There's hot springs, but there's no like moving water for the most part. And so that would be difficult to assess. But the borehole data might help a little bit, but that's somewhat limited as well. So from Sunbob, are the hills between the fissures and the power plant former volcanoes? If so, is the magma traveling under them or using the plumbing systems to travel? Yeah, so we have these old, let's get rid of the GPS, all these landmark hills, and I just have a few located here. There's one over here, there's a bunch over here, but these prominent hills around Grindavik are all subglacial volcanoes. But when they erupted, they produced very different rock types, and in general, their rock types are pretty low permeability. They're big piles of cemented and glued together fractured rock, and so they lack a lot of the fracturing. Now this one here has a couple big fractures running through it there, but for the most part they lack a lot of the fracturing and permeability that would be needed to transport magma. And so whatever plumbing systems they had, it's very likely they're not helpful or useful to the present situation. So what I'm saying is it's unlikely that you would see them actually have a vent open up somewhere on their summits or their flanks. I mean, even the Stora Stogafelt here, a lot of times these fissures run into this hill and they just stop. Is it possible that a fissure could cut through this thing? Maybe. But it's a very different rock type in terms of its permeability and stuff. So, okay, a couple more questions. Two more. Deb Prothero, on the east side of Grindavik, were there any farms or other properties affected by the lava flow, or is agriculture not possible on the landscape? Thanks for advancing knowledge. There are little farms there, but none was affected. Amanda Joe might be able to address specifically what a lot of the farmland here, when we use the word farmland, some of it's for cultivating crops, but a lot of it's for grazing sheep. And so I don't know specifically like what they're using their land for. Is it all sheep grazing? Are they actually growing things out of the ground? I'm not sure exactly in that sense. So yeah, interesting question. And then finally, Origami Jaspion, how is lava created? Oh boy. And how old is this lava we see erupting today? This lava was created days ago, weeks, months, years ago. Thank you for these amazing and fun classes, Shawn. So lava is created whenever you get, well, there's two ways that come to mind. Whenever you get, rock is heated up. So if you heat up rock beyond its melting temperature, you start to melt the rock. That's one way to create lava. So high heat flow is one way you can generate lava. The other way we generate lava in the planet is in a weird layer down below the crust called the asthenosphere. Whenever water is driven down into that, so at a subduction zone, you can drive off water at that subduction zone. It goes into the asthenosphere. It lowers the melting temperature and causes some magma to form. And that magma, once it forms, it tends to rise. It continues to rise until it reaches like some level of neutral buoyancy, depending on how much gas it contains or its composition. And And so those are a couple ways you can get magma created. The other way is at a divergent plate boundary where the plates are spreading. By taking pressure as the crust gets thinner over that divergent boundary, that reduces pressure on that layer called the asthenosphere, and that can trigger partial melting as well and generate magma. Once the magma gets to the surface, we call it lava. So how old is the lava we see erupting today? It is brand new. It is the youngest rock on the planet. So today there are rocks being born on St. Patrick's Day in Iceland, which is kind of cool. Right? And we can see that right here on our handy dandy webcams. There you go. There's brand new baby rock forming as this lava erupts and then cools and solidifies. So very cool. Okay, a couple more things from Amanda Joe. I think I'm good with questions for today. I can't run this live stream. Well, last night's was like 4.5 hours, so that was a marathon, but it was fun. Let's see. So she says lava approach to the ocean and expected to reach it, maybe? Oh, so maybe that flow's moving faster. So a natural disaster expert expects lava to reach the sea before long. He says it's important to point out it's not safe for anyone to stay nearby when it happens, as gases can be produced. Lava flows 20 meters per hour. He says there's still a lot of activity at the craters, and we can see that with the webcam, and a lot of magma still coming up. Lava flows in a southerly direction from the craters and moves closer to the road and towards the sea. So the northern one up by the power plant has stopped. He says that the force in the flow is too small for the lava tongue to move forward, but it will come in waves or pulses, so it could pick itself up again. So it sounds like he's expecting that it could progress, even though it's moving slowly, it might stay sustained enough that it could reach the road. Is that what I'm kind of reading there? So now it sounds like it's 350 meters from the road. So that far, if we can find the right webcam. Maybe I just had it, sorry, not that one. Yeah, this far end here, it sounds like it's getting closer. So, so the second lava flow along the defenses east of Grindavik is now only 350 meters. We can pull this over here so you guys can see it. Now only 350 meters from the lava flow reaching the southern road. This is what a natural disaster expert at the Met Office said. It's still moving a bit slower than this morning, but that can be due to the terrain. It has been accumulating in a lava pond, so it may be slowing down a bit, but there's still a decent flow, I understand. So the flow is quite slow. It's impossible to say whether the lava will reach the road today. And yeah, so it looks like maybe is that map a little bit more updated? No, it's pretty much the same map as the one we looked at previously. So yeah, we'll have to kind of see how this goes and progresses. Let me double check, make sure there's not anything new from the Met Office. Looks like nope, there is not, but they may put something out later today that would be of interest to folks. So how are we doing here, team? Let me give you something better to look at. So they're like panning down to the south. There's those two flows. There's the berm. And yeah, move that camera back to the left. There you go. So it sounds like it's getting pretty close to the road potentially. Oh, and Amanda Jo wants me to show a video. Yeah, so that's pretty good there. There's the berm. They're working just ahead of it, so the end of the lava flow is probably right here. You can see a slight little color change. So this black is lava, but the area out in front of the lava flow is where they scraped up the earth material to help build up the berm. And so you can see some people actually walking around down there in the vehicles. So that's just beyond the edge of the flow. So the edge of the flow looks like it's about here. We got the workers and some of the vehicles here, and then the roadway, which apparently is only about 300 or 350 meters away, and then another maybe 500 meters to the coastline. So it could get there if we, if this continues like the rest of today and into the evening, potentially, because this is all feeding it, and it might be feeding it in the subsurface. So even though this looks black, remember it's still molten just below the surface, and that's actually where it's moving. The stuff on top is cooled mostly and solidified, but it's being carried with it, so it's kind of moving from below. And Amanda Joe says there was a big discussion about taking lava samples, and so she wants me to show this little video clip. So we'll watch this real quick. And this is from today. So this was samples they collected today. So there's your classic lava flow team. So this is cooled off to the point where the viscosity is a lot more. So it's almost like a tank tread. It kind of rolls over the front of itself. There's lots of these little black rocks that are falling off of it. It's very sharp and spiny. So this person here is going to come in with their little scoop, get a nice hot incandescent sample, and then presumably quench it. So he's got to kind of dig in and get something nice and fresh, or she. Get a chunk and then put it in the bucket of water so it's quenched. And then apparently they're just, that's probably a geochemistry sample because they're kind of crushing it. And the protective gear so you don't get burned, just gloves, kind of like a welder's thing. Yep, so there you go. Thanks for sending that, Amanda Joe. Hopefully that was helpful. Or maybe you've seen the less professional version of that, which is a video of me with my rock hammer and my garden gloves and my long sleeve shirt on, collecting a sample from 2022. That's out there as well if you're interested. Okay, let's see what else we have here. Anything else? Okay, so Amanda Joe has a question, so we have to answer that. She says, if the lava gets closer to the ocean and the weather gets worse and the waves kick up higher on land and hit the lava, what would happen when it makes contact with the lava on land? So that's a great question. So if you had the lava, I mean, it'd have to be really close, right? So let's say the lava is 20 meters from the beach, from the coastline, and you get one of these big breaks or waves or swells that smashes into the rocks on the coastline and sprays that water. We've probably already all been there, right? You've been maybe on a really active coastline where the lava smashes into the rocks and kind of sends a big rooster tail spray plume up. Well, that water hitting the lava is not enough. It's almost like a heavy rainfall. It's not enough water to cause the lava to fragment. To really get this explosive interaction that we've talked about, you need to get an appreciable amount of water and lava involved. So the spray from the waves breaking isn't, you'd probably, if you were close, you'd probably hear the sizzling and that water quickly evaporating as it hits the hot lava, but it wouldn't cause those explosive interactions that we tend to see when we get lava and water interacting. You need a lot more water than that, than just the sea spray happening. So hopefully that was a decent answer, Amanda Joe. Really great question. And we'll have to just see moving forward throughout the day or the evening there in Iceland what actually happens with this specific flow. It sounds like the flow back up at the north end of the, whoops, here, this lava flow is pretty much over and done with. It made it to within a few hundred meters of the pipeline. We still have these small fissure vents active. I believe by this point with the February 8th eruption that it was really over. Like, and even the January 14th one, that eruption was like 3:30 in the morning my time, and we did get the drone up the next day to fly around, but we had to like hunt to look for any little red glowing spots. So my rough recollection is that this event is producing a little bit more sustained activity than what we saw in the prior two events in terms of time. But maybe that's not true. That may not be true. That may be just the way I'm kind of thinking about it right now. So, yeah, anything else outstanding there? If you pour water on lava, you do not get obsidian. They said just kidding. Yes, let's make sure we don't perpetuate that fallacy any further. So, thanks to all who have donated here. Jane Goff, I probably missed some folks in the live chat over the last bit. Hoosier who flies RC, thank you for your tuition installment. Here at the University of Willsey, we offer very generous rates on our academic programs, so thanks for taking advantage of that. Yeah, and Jane, thanks for your donation. You love the Road Cut series. There's one more coming out soon. I have one, what is it slated? The 22nd? Friday. So Jane and others who love the random road cuts, a new installment coming out this Friday. So I'm just kind of scrolling back here and seeing what's going on. Hopefully the moderators are doing well. Thanks again to Amanda Jo and Susan and Lisa for all their amazing work here. I think we're going to wind this down a little bit and call it good. We did do a marathon 4.5-hour session yesterday, and I've got a lot of things to get done today. We do leave for our Europe trip this Wednesday. My youngest son hopefully gets his driver's license test on Tuesday, so I got to take him to that. I've got to do a presentation on my sabbatical to the Board of Trustees tomorrow. There's a small chance I'll get one more Iceland update in on Monday or Tuesday, but let's go with a don't count on it kind of mental framework for that. But I do have some other videos coming your way while I am gone. So I'll be over in Europe from the 20th to the 30th. I'll take my laptop though, so if anything significant takes place, I'm sure Amanda Jo will let me know and I can jump on and we can share some stuff with you. But for now, I think we'll go ahead and wind this down. Thanks to all the great teammates out there that were able to jump on with us today. Thanks for your patience last night, especially as I was futzing with various webcams. Thanks for your patience and good-naturedness when I left the mic on and I was talking to my wife on the phone and trying to order food. All sorts of comedic things happening there. But I don't remember the light going off, so that we've managed to keep the light on. As I say that, it's probably going to turn off on me in a second here. Thanks for this great community we've developed here. I hope you enjoy the rest of the eruption. I hope you enjoy seeing what happens with that southern flow. And if it gets down to the roadway, of course, we will hope that it can end soon and not cause any more damage to the Icelandic infrastructure. But let's also celebrate the defensive berms, those barriers that were erected. I think that was a great proactive mitigation measure that I think is paid off in spades here. And so I think it'll be a lot easier for some of these other areas at risk, like at the north end of these systems around the capital area. I think in the future you might see some of those mitigation structures being erected around the capital region as well, just as they start thinking more about the Reykjanes area and the potential for future eruptive events. So we'll go ahead and sign off here. Make sure you like the channel, give it a good thumbs up. I guess, I don't know where it's at, but I guess when I get to like 100,000 subscribers, something cool happens. There's like a plaque that just do like the YouTube like angels swoop down out of the heavens and bestow some cool plaque upon me. I don't know. It's a fun number to think about, but that's never been the goal of this channel. It's always been to share geologic information. If you go back to my very early videos when I had like literally hundreds of subscribers, I think you'll find that I'm the same person and I am passionate no matter what. So hopefully that comes across. But I do appreciate having such a big audience. I appreciate the moderators who have been able to join us. Thanks to Amanda Jo for all her hard work in getting me the information, and to Susan and Lisa as well. But we'll sign off from now. Look for some new videos from me this next week. Thanks again for joining me. Have a great day. Happy St. Patrick's Day. A very happy St. Patrick's Day. I need to put green on. Oh my gosh. I love a little bit of green on my watch. But my name is Sean Patrick, so maybe I get a pass for that. I don't know. But I will go get some green on for the day. And it's a nice day here in Idaho. I hope you have a great day wherever you are. Thanks again for joining me. We will be sure to jump on whenever there's another significant geologic event, whether that's in Iceland or elsewhere. And have a great day. Appreciate you. Bye now.